Welcome to aminacademy.com. Let us discuss about logarithms. Some introduction will do. Logarithms are commonly credited to a Scottish mathematician named John Napier, who constructed a table of values that allowed multiplication to be performed by addition of the values from the tables, and division of two numbers can be used by log by subtraction of that two log of that numbers. John Napier introduced a concept of logarithms in the 17th century. Later it was used by many scientists, navigators, engineers, etc. for performing various calculations, which made it simple. In simple words, logarithms are the inverse process of exponentiation. In mathematics, logarithms are the other way of writing the exponents. A logarithm of a number with a base is equal to another number. A logarithm is just the opposite function of exponentiation. For example, we know that 10 square is 100, then log of 100 base 10 equal to 2. That means if you reverse it, 10 square equal to 100. Hence we can conclude that log of x base b equal to n, then b power n equal to x. For example, log of 10, log of x power 10 equal to y, suppose, then we can say 10 power y equal to x. That is, this is logarithmic base 10. Then we can say it is equal to 10 power y equal to x. That is a reversing like 10 power y equal to x, where b is the base of logarithmic function. Here we took 10 is the base. This can be read as a logarithm of x to the base b, logarithm of x to the base b equal to n. Then you can say in reverse, that is a power form, that is b power n equal to x. Now look at this, some examples below are some of the examples of conversion from exponential forms to logarithms. Look at here. We know that 6 square equal to 36. How to make a log is log of 36 base b equal to 2. We are using common basis b here. 10 square equal to 100. Then you can say log of 100 base 10 equal to 2. 3 cube equal to 27. You know that log of 27 base 3 equal to 3. Here, whichever here, that is the base. Here 3 is there, the base is 3 here. Now some types of logarithms. In most cases we always deal with two different types of logarithms, namely common logarithms and natural logarithms. A common logarithm is also called the base 10 logarithms. If it is basis 10, even you are not, suppose normally you are not reading the 10, that means log of x means log x base 10. It is represented as log 10 or simply log, you can say. Log of base 10, we can say it is simply log. For example, the common logarithms of 1000 is written as a log of 1000. It is a base 10 is hiding here. The common logarithm defines how many times we have to multiply the number 10 to get the required amount. That means, for example, log 100 equal to 2, which means, look at here, suppose we are using base 10, which gives 10 square equal to 100. If you multiply the number 10 twice, we get the result 100. Natural logarithm, and the natural logarithm is called the base e logarithm. The natural logarithm is represented as ln or natural logarithm. Here E represents the Euler's constant, which is approximately equal to 0.71828. For example, the natural logarithms of 78 is written as len 78. It means base is E here. The natural logarithms defines how many we have to multiply E to get the required output. That means E must be multiplied how many times to get here 78. It means len 10 means E must multiply how many times to get the 78. For example, len 78 is 4.357. That means E must be multiplied this much time. Means E into E into E into E 4 times, and 0.3 is the power of that one. Thus the base of logarithm of 78 is equal to 4.357. Logarithms, rules and properties. There are certain rules based on which logarithmic operations can be performed. The names of these rules are product rule, division rule, power rule or exponents rule, change of base rule and base switch rule. Here the product rule. In this rule, the multiplication of two logarithms value is equal to the addition of their individual logarithms. Look here, log of base b into mn, that is product of m and n, which gives log of m base b plus log of b base n. That means multiplication of two numbers become addition of that numbers with some logarithmic basis. For example, log of 2y base 3 is log of 2 base 3 plus log of y base 3. Means this is splitted as addition. 2y is splitted as log 2 plus log y. Division rule. The division of two logarithmic value is equal to the difference of each logarithm. That means log of base b m over n. The division becomes subtraction. That is here log of m base b minus log of n base b. For example, log of 2 over y base 3 is log of 2 base 3 minus log of y base 3. Exponential rule. In the exponential rule, the logarithms of m with a rational exponents is equal to the exponents times the logarithms. That is log of m power n base b, which is equal to this n come the front of the log, that is n into log of m base b. Remember, this power n comes front. For example, log of 2 power 3 base b equal to same, that 3 come front, that is 3 log 2 base b. Now change of base rule. Here log of m base b can be, the base can be changed like by introducing another base of a, log m base a over log b base a. We are introducing another base, the required base is a here. So log m base b can be written as log m base a divided by log b base a. For example, log 2 base b can be written as log 2 over base a divided by log of b base a. That is here change of base rule. It's useful some calculations. Base switch rule. Suppose here log of a base b can be is written as 1 over log of b over base a. Means here base b is switched as a base a when log of a base b is equal to 1 over log of b base a. For example, look at here, log of 8 base b can be written as 1 over log of b base 8. Means this base and number is interchanged here, that is b and 8 changes 8 and b with 1 over log of that one. Some logarithmic formula, we can summarize this formula. Log of m n base b equal to log m base b plus log n base b. Addition rule already we discussed, and division rule is same like log of m over n base b equal to log m base b minus, here for division become minus log of b log of n base b. Next is power rule. Log of x power y base b is equal to y confront. That is, we are summarizing the rules. Y log of x base b. Here, this is not here now. Next is here log of x base b into m and n into log of y base b. First we have to go the power rule as log of x means here, look at here, log of b base x power m plus log of y base b over n. Now use the addition rule, which gives log of base b x power m into x power n, which is equal to log of base b x power this enough. Here this is now logarithms is very useful in scientific approach. Here logarithms are used in many situations as logarithm scales. The most common example of this are pH values, sound and earthquake intensity. They are using logarithmic scale. Logarithms are used in psychology, music and other fields of study. In mathematical modeling, logarithm can be used to assist in determining the equation between variables. Logarithms were used by most high school students for calculation prior to scientific calculation being used. So far we have done some introduction about logarithms. Now further videos we will discuss very detailed about how we are using logarithms in calculations. We have done. Please subscribe our YouTube channel.